Okay, so differential equations. Differential equations in mechanics tend to be linked to a Newton's second law equation. So the context of the question will enable you to use Newton's second law to form a force equation. So you're going to have something F equals ma, and then to turn it into a differential equation we can replace the a using this with dv dt. So then your equation is going to become F equals m dv dt, where they will have given you a mass probably, and they might have given you a force, and then you will solve that using separation of variables to end up with an expression v in terms of t. So solve using separation of variables, just like you did with the pure question, to find v as some function of t. And remember, because you're going to be integrating about constant, to make sure that you put a constant in, and then using some initial conditions that will be given to you in the question, you would then substitute in to work out what that constant is. Then we come to vectors. Now vectors are where we introduce i's and j's and sometimes k's into the maths, and it can pop a vector question could be pretty much anything. It could be a projectiles question, it could be a variable acceleration question. It depends on how you're given, but basically they aren't anything to be frightened of, because when we are working in splitting things up into x components and y components, to all intents and purposes that is turning it into a vector form. The x components are the I values and the y components are the j values. So we've been doing it all along anyway. So rather than split into x and y components, values are combined using I and j. So you could be given a force, F equals 2I plus 3j. And what that means is that this force, the x-axis is each unit is an I, and on the y-axis each unit is a j. So this force is going 2 in that direction and 3 in that direction. So 2i plus 3j would be represented on a graph looking like that. It could be written as a column vector instead, and that is the way that I would tend to write vectors. So 2i plus 3j is the same as a column vector 2, 3. And from that vector form we can find out the magnitude of f, which is basically how long the hypotenuse is, and also the direction, theta. So in order to work out the magnitude of f, so how big the actual force is, that would be the hypotenuse there. That side is 2, that side is 3. So using Pythag, it would be 2 squared plus 3 squared. And the direction would be opposite over adjacent, which would be 3 over 2. And opposite over adjacent is tan. So to go from a vector form, 2i plus 3j, or 2, 3, you can calculate the magnitude and the direction using right angle trig and Pythag. You could be given force as a vector form. You could be given position as a vector form. Position tends to be given as r, okay, but it could be displacement as s, and that could be something like 2ti plus 7t squared minus 1j, which would be a variable acceleration question. Okay, or you could write it as 2t 7t squared minus 1. The magnitude of r, so the Pythag bit of that, would give you distance from origin. If you had a velocity vector, then the magnitude of velocity gives you the speed. So we'll look at a practice question on Thursday to do with vector notation, but it isn't anything to be panicky about. Then the final run of sort of revision boxes are all to do with projectiles, which is another fabulous topic in mechanics that sadly we didn't have anywhere near the opportunity to have fun with online as we could have in class. So first of all, we look at what happens at the point of projection. So if a particle is projected, let's say it's projected with an initial velocity u, and it's projected at an angle of theta to the horizontal, a projectile has no means of motion other than the initial velocity it's given and the acceleration due to gravity. And what we do is we, just like with components of forces, we work with horizontal and vertical components, or i's and j's, if it's a vectors context. So ux would be u cos theta, and uy will be u sine theta. The only thing that's making it move is its initial velocity and then acceleration. So the particle accelerates under gravity only. So it's got no acceleration in the horizontal plane. Its only acceleration is g, and g wants it to come to ground. So if it's being projected upwards, the acceleration due to gravity is minus g. That's the only thing that's happening. All the equations that we generate for projectiles come from the year 12 ones. Okay, we use that one a lot, we use that one a lot, and we use that one a lot. These ones are more archaic. You can use them, but we very rarely do. So that's our setup, is splitting the initial velocity into its vertical and horizontal components. While the thing is in flight, if we want to look at where it is at time t equals t, so it's initially projected here, u theta, that's a time t equals 0. Its flight is a sort of parabolic arc. Put the green pen. So its flight is going to go like that. It's going to rise, it's going to reach a maximum height, and then it's going to start to fall again, and it'll come back down and hit the ground. What I'm interested in here is at any point where t equals t, the position, the xy position, the horizontal position and the vertical position of that at time t equals t. So we know we've got uy is u sine theta, and we've got ux equals u cos theta, and we know that ax equals 0. So using s equals ut plus a half at squared, horizontally sx is its position, u is ux t, ax is 0. So that's all gone to 0. So that's equal to uxt, which is u cos theta t. Vertically, y would be uyt plus a half ay t squared. So we're still using s equals ut plus half at squared. Uy is u sine theta t, and ay is minus g. So that will become minus a half gt squared. So if I want to know where that is after 2 seconds, and I know more information about how it was launched, so its initial velocity and the angle that it was projected at, I could put t as 2 into there, and I could work out what that value is. I could put t as 2 into there and work out that value. Or if the question asked me if the question asked me at what time is it at a particular position with x is 2 and y is 1, for example, then I could put x and y values in there and work out the corresponding value of t. So that's what happens in flight. The next thing that happens is this is going to hit the ground again. So when it hits the ground, that's Mr. McGovern ringing me and I'm ignoring it. What happens at this point of impact? So if we look at the start again, who is determined? There you go, it's gone. So this is going to fly. Oh, I forgot to mention here maximum height. At the maximum height, at that particular point there, it's stopped moving vertically. So at that point, for the instant, at instant of max height, the y component of velocity equals 0. So at that maximum height, Vy is 0. So you can then work out what time it reaches this maximum height using V equals u plus at. U is uy, a is minus g, v is 0. So you can work out the time at the maximum height and various things like that. So that's another key fact. So you've got ax is 0 always. At the maximum height, Vy equals 0. Once it's gone beyond that instant, it starts to fall again, so Vy becomes increasingly negative. Back to this one. So there's my u, there's my theta. When this hits the ground, it's going to have a Vy and a Vx, and that will give you its speed of impact. You also know that if it takes off and lands on the same plane, that is going to have an x coordinate sx, whatever that horizontal distance is, and it'll have a vertical displacement of 0. It's come back and landed at the same distance. So you may well get a question which asks you to calculate the speed and direction that the particle is travelling when it hits the ground. Because AX, so if I make that a bit bigger down here, Vy, Vx, V theta, what we've got is a right angle triangle. Vx, because ux equals, ax equals 0, Vx equals ux plus axt, v equals u plus at, that's 0. So the x component of its, the horizontal component of the particle's speed is fixed throughout the whole journey. It doesn't change. It's equal to its initial velocity on takeoff. The Vy, we know, is going to be Uy minus Ayt. So I know Uy is u sine theta, so that will give me, I can work out the time of flight. That means I know what Vx is, I can work out what Vy is. V is going to be Pythag, it's the hypotenuse, so that would be Vx squared plus Vy squared. And the direction is usually the angle below the horizontal, which will be tan to the minus 1 of opposite over adjacent. So to work out the speed and direction of the particle when it hits the ground, that's what you're going to do. And then the only other little fun that we have in mechanics with projectiles is we have a situation where the thing is projected above the point of impact, or it hits below the point of projection. So let's say that we've got a situation here where it's launched 10 meters above the ground. All that means is that when you're doing your maths at this point of impact here, that is going to be horizontal distance Sx, but the vertical displacement is going to be minus 10, because you know it's going to hit 10 meters below the point of direction of impact. So again, depending on what you're given here for u, you know you've got your uy, you know you've got your ux, 10 meters below point of projection. So Sx equals ux t, because the half at squared is going to be 0. Sy will be minus 10 equals uyt minus a half ayt squared. Vx at that point is equal to ux, because the a is 0. And Vy will be uy minus gt. So those are the 4 equations that you can use to answer whatever the particular question is asking. So although projectiles is something that sadly we have to do all online, it's in all intents and purposes it's just using mostly v equals u plus at and s equals ut plus half at squared. Okay, so we'll have a practice at that on Thursday when we take a look at a practice paper.